everybody. I'll get going in just a moment here. Just running a little behind because I just I'm in the weeds. All right, how are we doing? Everything sound okay? I knocked the filter off my microphone, so hopefully it's not too unfiltered. I don't even know what it would be like. All right. Let's see, DCD on Discord. Oh, and you probably heard that. Hello, DCD. How are you doing? It's clear. Good. Awesome. Thank you. Let me turn on this other light that doesn't like to stay on. I flipped it. And it could probably be a little dimmer too. All right. So I'm coming in a little hot because I got distracted by what I was working on. Okay, so hello everybody. I think I'm all set up. My name is Scott and I work on CircuitPython for Adafruit. So Adafruit is an open source hardware company based out of New York City, and I work on the software side. Hello, Johnny. I work on CircuitPython, which is a version of Python designed for little tiny computers called microcontrollers. Let's see, I got lots on my desk. Here's a clue. So this is a microcontroller board. So we would call this a development board, where it's a circuit board here. Designed by Adafruit. It's got a microcontroller under this little can here. They call it the can. It's a piece of metal that shields it because it's got radio stuff. So you'll see this on radios to protect it from other emissions and stuff. Tyus says, sounds good here. So Adafruit makes circuit boards like this one, development kits like this, and teaches people how to build all sorts of stuff with it. And inevitably, you need some software, and you need to be able to program it to do what you want. So I work on CircuitPython, which is a version of a programming language called Python, designed for controllers. So many of our CircuitPython supported boards, you plug it in, it shows up as a drive, and you edit code on that. So this is a deep dive where I talk about kind of what I've been working on, and if folks have questions, I'm happy to answer them. I do at least an hour, but I've been going over a little bit since then. So that's kind of what it is. I've been heads down all day and trying to figure stuff out. So last week and this week, so in CircuitPython 2026 and thinking about this year in general, I've been thinking about what I want to accomplish and how I want to accomplish it. Now, I read my CircuitPython 2025 and it was like, yeah, we want to do Zephyr. And that's still very true. I still want to do Zephyr. I was out like roughly half last year because I was watching my youngest kiddo. So I'm kind of back full force into it. And since then, these LLM, large language model agents, have come up, which allows you to tell in human words what you want to achieve. And then using tools, an LLM can get more context on the code that they're talking about, and then perform some things like editing files and things like that, and running commands. And that's really, in my opinion, a game changer. I've had days where it feels like I'm getting a lot done and things work, but the reality also is that while I feel like I'm getting a lot done, I've actually not been doing a lot of pull requests, so not a lot of changes. And so some of that has been that large language models make it really easy to create tools. So there's a couple tools that I've been coming up with in the last week or two. One I showed, I think last week, the breadboarding thing. And that's made it some ways, but I moved off of it today and yesterday. So the challenge that I'm having is that because large language models make it so easy to hop into something, and there's this idea that you can say think about a project and send it off and it'll generate a bunch of code for you. The problem is that after you've sent it off and it's generated a lot of code, like now you need to actually verify that it did what you asked it to. So I do have, let me switch to the desktop here. So I talked about this last week where I'm trying to do like kind of having 3 workspaces open at once. So I'm using virtual desktops now, which I've not done before. Hi Hams Labs says, much has been happening with me in agent coding. Yeah, how's it going? I think that the people that are worried that it's going to take your job need to try it on a day-to-day basis, because the reality is that, like, yeah, it's still bottlenecked on me. It makes some things easier and quicker, but like I'm still not getting infinite work done, right? Like without the agent. Like I barely used it today. I've used it for a few small things, but primarily, so these are OG, like my original CircuitPython folder. YOLO, which was one I created originally to just see what it does. And then left field was like further, like the idea that it's kind of like out and about and far. But I switched to these so that I can have like I kind of have a traditional setup of like Sublime Merge and and Z Editor and like multiple programs running kind of within like one context. And so having the different virtual desktops let me isolate those. So primarily what I've been working on in the YOLO one here is trying to get, like, because it's easy to start a bunch of things, it's hard to know which one to finish, is one thing that I've been finding. So like I've got these big things pending, but the reality is that just because the code's written and the agent claims to have written tests doesn't mean that they did it right. And so, but it's like it's easier to get distracted by those things. That's not to say that they're not doing like a non-trivial amount of work while they're doing it. It's just to say that like it can be a little fragmenting for my brain. And the week started off with our youngest like getting up in the middle of the night a couple nights. So I think part of it's also been that like I'm like not quite fully slept. Like I'm a little sleep deprived, and that's making the focus harder too. So I came in today wanting to like really try to get this BLE stuff done, and I didn't like the way that it had done the test structure for the bsim bsim stuff. And so I was trying to rework that and to like abstract away some of the like serial connection stuff. And that's basically where I'm stuck. I'm stuck in that we have a bunch of different serial connections going all at once during this during the test, and at any one point we may want to like synchronize on serial output from one process or another. So in the bsim case, we have what's called the like phi. So it's like the thing that pretends to be the air or the like the RF environment, and then there's like 2 copies of CircuitPython. Let me show you, because I did the basic ones yesterday. So I redid the harness yesterday using the basic tests, and I'm really happy with it. So now you can say, hey, I'm doing test blank output. I need a copy of CircuitPython, and this is what's on the drive. I've learned more about pytest than I think I've learned before. So Taya says, give a concrete example of all the serial connections for one test case and example. So let me talk about it here, and then we'll go. Let's do the simplest case. So in the case where we don't have a drive at all, so it basically means the flash is blank, we are just testing like, hey, take CircuitPython, wait until it's done, whatever done means. So, well, what done means is that by default, the native sim processes will run for a particular amount of simulated time, and then they're done. So once it's done, so CircuitPython.serial, and then there's also a CircuitPython.debug serial. So every CircuitPython process has two serial outputs. One is the serial where you get the REPL, and then one is like the print debugging serial. And so I'm trying to say, okay, get all the output from the serial, and then let's make assertions about what's showing up. And that's all we're testing here. So that's quite simple, and I'm really happy using this process. And then just saying like, hey, I need CircuitPython with this drive and this different code. I'm pretty happy with that. And now you can see here that I'm doing more things like, okay, run this code and wait for it to print out loop 5. And once it prints loop 5, control C it. And then make sure that that shows up in the output. So there's like starting to be some software load things. And I do want to test. I think there's a subtlety in CircuitPython where when code.py finishes, you actually are supposed to clear the pending serial input. Otherwise, what you'll do is when your code.py finishes, you'll run right off into the REPL, because the REPL is like, you enter the REPL when you press any button. And that can happen if you don't clear when code.py is done, then you can end up falling into the REPL even though you didn't expect it. Hams Lab says, I finished my thing using a Wio terminal as an IRTV. Cloud Code did something amazing with this. I believe it. I mean, you know, I should be trying Claude as well. I've been driving Codex all day. I wonder, I should try opus 4.6 to see if it can figure out my problems. So the CircuitPython argument to the test has one used serial mostly, but occasionally you're using debug serial instead of serial. What about two devices like a UART to UART test or the Beely example? Right, so these arguments are deceiving. This is something that I've had to learn about pytest. Like pytest is calling this, and so when you put CircuitPython here, it's actually calling a test fixture. So if you say CircuitPython here, what it's doing is before the test is run is it's calling this function. And then this function is generating something. And what's cool about the test fixtures is that you can yield the value that you want to go into the test. And then when the test finishes, you can actually do things afterwards. So what I have it doing now is that after the test finishes, for every instance of CircuitPython, one, shut it down, and two, print all of its output, both from the regular serial port and the debug serial port. And those prints get captured by pytest, and they only show up if your thing didn't work. So only if your test fails do you see this stuff. But that's like super handy, I think. Yes, I figured this part out. So Taya says, injecting arguments to functions test fixtures, so you really need a way of newing up factory create an ID-based device. Yes, so I've gotten that working. So if I've made a separate folder now for bsim tests. And in bsim, I have CircuitPython 1 and CircuitPython 2. And then if you look back in the original CircuitPython thing, it actually looks for, it can get all the fixture names, and if CircuitPython 1 and 2 are in there, then it returns 2 instead of 1. Hamzab says, you spoke of setting up a Discord channel for AI coding discussion. Made 2 simple websites, specify resistance, they'll show you the closest standard value. Yes, so we do have that chat now. It's called Coding-Agents-and-llms. I did make it. And I'm behind on the discussion there. But it's good. It's really good. And yes, I'm still learning the boundaries of what these things can do. I have a separate side project where I'm tracking the state legislature and the bills that are going through. And I've been I'm also tracking the people that sign in pro and con when it's time for public hearing about a bill. And I was graphing like over time when people sign up, and it was only showing between 0 and 12, not full 24 hours. And I was like typing in with it, and I was like, why isn't this not working? And I thought it was a time zone thing, and then it just like out of the blue said, oh, that's because you used the wrong string parsing, the wrong time parsing letter. I'm like, it found my bug immediately, and then I was like, and then I groaned because I was like, like I gotta rerun all these imports because I have it. Love the Factory says, which Adafruit board has the best implementation of Zephyr? So I did get a little hung up on that. So when I was doing the breadboard testing, I was going to use the itsy bitsy NRF 52840 as a test, and it didn't start up. And I realized that there's some changes in the BLE branch I have. So this is another challenge that I'm having with agents and doing a lot of stuff in parallel, is that I end up fixing multiple things in the same branches as I'm going along. And I think that's the solution to that is being a little bit more disciplined about keeping my changes small and doing them right away. So like I had this fix about memory use that's in my BLE branch that I could have just split off and gotten in and checked in, and it would fix things. So I think like part of working with agents is really being disciplined about finishing small things, or even splitting small things off so that you can share them across your branches. So one thing I'm thinking with the BLE stuff is like, I know I'm just gonna like expand out all of the BLE stuff that I want tested, and I want to establish like what how I want the test to look. And so I can't do anything BLE wise until I get the test looking like I want. And even then, like I redid the like basic test as well, and so that applies to anything as well. So I'm I'm the bottleneck, but that's because I'm being choosy, because I want to set a good example in the code that I have in this part so that agents can duplicate it. Did I answer your question? Love the Factory. Which Adafruit board has the best implementation of Zephyr? So it is on my radar to start having a few Adafruit boards that have dual support. That maybe have like the Nordic, a couple Nordic ones, like a couple NRF 52840s will be the first Zephyr ones. Taya says, I was surprised to learn that a lot of people are not aware of the free hosting available via GitHub pages. Put in a friend recently at it for their girlfriend's cloud website experiment, custom domain, maybe costs and everything. Yeah, it's great. So this like legislature tracking site is all GitHub pages, and it's not small at all. It's like thousands of pages, thousands of like tiny files. It's called wa-law.org. And this is all hosted on GitHub, even though it's a custom domain. So, and the view trace thing I did as well. Love the Factory says, any with Ethernet yet? No, there's nothing with Ethernet yet. One of the branches that I have where I'm like squirreled it off and like started is testing, setting up testing using the host side networking in the native sim, and it seems to work. So it's in that like gray zone of like it seems to work, but I haven't had a chance to look in detail. So I'm also thinking about like I feel like there's something missing for me managing like the state of all these different branches. And if folks have suggestions, like this year is very much a year where I'm like learning to work in a different way, and part of it is how do I manage multiple threads that are like threads of working on stuff that are in different states, because like if I'm on a clean slate, I can actually kick off 3 things at the time and figure that out. Ty says, not having 5 fixes in a PR, my crime this week too, means you want to continue new features on top of existing open PR is not great. Yes. Being more disciplined is definitely the solution. Break into small fixes. Then by all means, having testing branches with a few merged. Yeah. Yep. So I'm there too. Like, so that's why I'm like really like, I'm trying to get myself focused on the BLE stuff. And then, but then I've been running into this testing issue. So I will show you one other thing because so like tooling is a bit, it's a superpower, but it's a bit of a trap. It works pretty well sometimes. Like being able to tool is pretty handy. Like last night I was doing this legislature thing at night and I was like trying to match up. I got a list of all the voters in Washington state and I was matching up the people testifying with voters, and I did that all by agent coding, and it did just fine. It was great. So that was a use where it's like really cool. And when I was doing this test refactoring, I did one file and then I told the agent to do the second, and it just immediately did it. It was great too. So there's like a lot of learning happening here. Another thing that I did was, so we're in this thing. I did git review web is something I'm experimenting with. So one of the bottlenecks I perceive is that agents can generate a bunch of code, and I don't have a great way to review it kind of like along with the agents, to say so. So I was experimenting with this git review thing. So it started up a web server, and it's behind here. So I totally vibe coded this tool, but it's showing me untracked files, and I have some actions I can do, like I can remove them. And then it's showing me a diff. So it's like a hunk by hunk diff here. And I don't know why there's a read line with timeout. So this is when LLMs have trouble, they tend to just add and add and add and add, which is not great because you end up with a lot of stuff. So like this is like junk, basically. Like we don't need this. So I could just delete it. So actually I'll just delete it. Discard hunk, delete it. Like I don't want it. And then this is a change that I think I made, which I do want. So this is very similar to Sublime Merge, except I wanted the ability to like give feedback kind of when I'm doing this review. So you'll see that I have this thing here, and it actually, if it works like it's supposed to work, I'm not going to do it right now, but it's like a way to like start Pi up, which is like the harness I'm using. So you could say, don't do it like this, and then it automatically adds context about like which hunk I'm talking about, and then gives it a chance to like work on it. So I'm playing around with that. It's kind of handy. I wanted so one of the challenges would like GitHub really wants you to do it in GitHub, but GitHub is like, in my opinion, kind of a place for humans. And like what I'd really prefer is that like the iterative process with an LLM, whether an LLM is reviewing your code or you're reviewing LLM code, should happen off GitHub, or at least in a different branch, right? Like away from where humans are going to do, because LLMs are super noisy, right? Like they find stuff, but they're just like a lot of noise. Even if there's a signal, the signal's not from me, for example, right? Like if we had this PR that somebody was doing, and they were doing back and forth with Copilot code review, and it was like, no. Like I don't want it there. I don't want it on RPRs. I want you to do that before you do RPR, right? Like I don't want to see it. Do it before you make a PR, please. Like I'm not saying the feedback is bad. I'm just like, that noise is not for me. That noise is for the person that's making the PR. So this was my personal solution to this, was like, it's a way for me to review it and give feedback to an agent that can go ahead and make the changes that I want based on the diffs. So Hamslab says, here's the Claude code thing. I wanted to use my Wheel terminal as a TVR remote, mainly for mute. I used a flipper 0 to read the codes. I decided to compare Codex and Claude. Tried with Codex and it got the buttons drawn on the display and I could navigate using the thumbstick but didn't get the IR codes right. It iterated a few times before I gave up. I then tried with Claude and it basically did the same thing until it decided on its own to examine the flipper 0 source and realized it was making a bad assumption and fixed it so the flipper sees the code. I was blown away. Yeah. Yeah, it's a great tool. Like, you know, the thing that I was pointing out with my CircuitPython 2026 was like, you should try it. You should try it and just see, like you're saying with the Hamslab, like, there are things it's going to be good at. There's things that it's bad at. So another thing that it's particularly bad at was I was working on the Breadboard tool earlier this week, right? Which is this thing where you run, it says place these here and here and connect them up. And it had a lot of trouble. This is scope feature creep, but I had realized that like, oh, when I first thought of this idea of like Breadboard, I was just picturing like outlines on it. Actually, you know what? I have the overhead hookup. Does it? Let's see. Maybe I could just show it. Oh, you know what? I was supposed to do a blog post today. See if the overhead. It's starting up. So I showed this on show and tell. I need to add it. Bench cam, window cam, Magewell, HDMI capture. Is that what it is? There we go. Except it's motion JPEG. Oh, that doesn't. Oh, that does look great. All right, let me reorder it. There we go. So I had a lot of trouble. Let me take these off. Oh, and of course, it's not actually showing you anything. Here, I thought it was working. All right, well, that's what it looks like, but it's frozen. So my idea was that the places that the devices are, you would get a picture basically. So like every little, I can't point to it because the video is frozen, but every little spot on the breadboard has its own LED. And so I had this breadboard command take in the fritzing, map a grid of, figure out the pixel colors at every point, and then produce an image, like a low poly bitmap of the device and place it on the device itself. So you just, yeah, it's really, really crisp. It's just not motion at all. Yeah, but I did that, but I think what the point I got is I think that the breadboard command is working, but the itsy bitsy firmware using Zephyr is not working. And I think that's because of this memory fix that I have in the Bluetooth side of things. So I'm just like, I set that aside. I want to finish this BLE thing. I'm not sure how I'm going to do it, but Like that's what it's kind of like at the point of like I really need to focus. I'm kicking. Go back to my desktop. So the one thing I have been poking in the side is display support. So I've got this. I've got this thing. It's trying to implement display I/O. On top of Zephyr has this notion of a native display, and so I'm trying to get that working, but it's not showing anything. If I do TO, it should start, but like the display doesn't show anything. Yeah, Labor was asking me to be more vocal about the Zephyr stuff that we're doing, but I'm just not like, once I finish the BLE stuff, I'll feel better about it. I've been in the weeds. And I'd love to get displays working too. So when I first asked the agent to do displays, I asked it to do it using the frame buffer method. And then it realized that like some of the displays don't support the frame buffer method. You have to write like individual parts of the display, which actually better aligns with the way display I/O works, but it doesn't work. Like it wasn't able to get it working like it was able to get the frame buffer version working. And even then, the frame buffer version it was working. It was like yeah, so Ty says, or maybe it's showing everything and you're giving it RGB, not RGBA, so the alpha's 0. Yes, I thought about that, but it's convinced it's working. Because if I type in here and actually do display, let me see, I want to put it here. And then this. So I'm getting a bigger monitor. As part of me like rethinking my thing, I was like, I want a bigger monitor. Oh yeah, I can rant about this too. It's a true deep dive talking about random stuff. I bought a new monitor last week. It came on Monday. I set it all up, and when I bought a Samsung G9 OLED, I set it all up and immediately went, ugh, I hate it. OLED. This one. So I wanted more space. And because I wanted more space, I was like, oh, I'll try these. Like, I love ultra wide. This one's called what is a form factor that's called a super. Sorry. I can hear my CPU going because this is running. I was like, oh, great. Like, I have an ultra wide. It would be cool to have a bigger ultra wide so I can have more space. And then I bought this OLED because I love OLED displays on phones and stuff. And then I set it up and I was immediately like, I hate it. Like I have the current monitor I have is a Dell. It's got the same PPI as the new OLED did. But apparently with the quantum dot OLEDs, the colors are arranged in a triangle. And so the green dots end up above the other two dots. And so for all of the edges, of windows and stuff, they had a green fringe on the top and like a blue-red tinge on the bottom. And I was just like, I can't do it. Maybe I sit too close, but it looks terrible. I can't do it. And I just spent a bunch of money on this monitor. So I just packed it back up and I returned it. And I ordered a bigger Dell that is not an OLED. I ordered the 40-inch ultra-wide and I'm on the 34. Anyway. Yep. I have no idea actually how to Architoethus Flux. I don't actually know how to pronounce it. The person who made Jumperless. Hams Labs uses a 52-inch 4K TV. I assume you're using it as a monitor. But yeah, so I think Tuesday I should get the new monitor. And I'm excited about it. It's got higher pixel density, so my text should get even better. But the screen's bigger, so I should get more space. And it's got a 120 hertz refresh rate, not 60. So it should get smoother and stuff too. So I'm excited. If you're in Seattle and want to buy this old monitor off me, let me know. Yeah, so this is another thing where it's like it thinks that it's working. Like, it thinks this is okay. Like, I had to do golden images for it. You know what? We could open it in open with GIMP. If we delete the alpha channel, or do like it thought that it didn't have, see, it thinks it's gray. Something's going on here. I wonder what exactly. Only index images have a color map. How do I see what color that is? I wonder if it's like 20, it's doing 16 bits into 24 bits or something like that. I bet that's what it is. Where it's like, it's reading the pixel colors and being like, that looks good. Colors. Load RGB. No, it's just gray. B and C. It's not working. So, like, I tried. I bought one of those ultra wides for gaming, but it turns out the resolution was too high for NVIDIA's hardware encoding. It maxed out at 4096. Yeah, so I was able, so I have a 6600, AMD 6600, and it was able to drive the giant 49-inch, which is good. I just needed a better cable, but I'm not using it for gaming. So I think for not gaming, I'll be all right. I don't game on this. I used to game on this computer when it was at home, but now it's at the office, and so I only use it for work. Okay, so let's pop the stack a number of times and get back to what I'm trying to get working. So let's stop the code review stuff. And so for bsim, so we talked about in the simple case where I'm just doing one CircuitPython instance, you have two serials. One is done through a PTY and one is standard in and standard out. And then, but with bsim, now we have two copies. So we have three processes. We have the phi, which pretends to be the RF environment. And then we have CircuitPython 1 and CircuitPython 2. And we can give it multiple CircuitPy comments or marks. So marks are pytest's way of like feeding back information about the tests to the fixtures. So the fixture that creates the CircuitPython processes knows it needs two, and so it finds that expects to have two drives, two marks of the same name. And then it generates them separately for 1 and 2. So it's a simple test. The reason that I wanted to do this, and I'm glad I did, is that these three things are run as separate processes, but they're kind of interconnected. Like the simulator phi thing doesn't run until it has as many devices as you tell it to expect, and then like the simulator itself is what's orchestrating time of the two other simulators. And so I'm trying to orchestrate those things, and they're running concurrently, and they're outputting to standard in and standard out. And the CircuitPython ones are also outputting to PTYs. And so I just have this problem that like I'm not able to like get the synchronization right. So I can just run it. And now it says threading is not defined, which is weird. That's a new one. In Serial Saver, did I delete it? Or I was experimenting with it? Or did I accidentally delete things? Okay, so we'll add threading. So I've been doing most of my coding by hand today. I've done a few things with the agent, small things. Okay, so here we found that. So this is a case where it's like, oh, it didn't work. Oh, let me make it bigger. It didn't work. Why didn't it work? So, there's two serial exceptions. So interesting. It booted twice. Previous lock file found. Can't establish with devices. So I have this problem where I'm leaving rogue processes around when things don't clean up correctly, which is annoying. So I have to kill 2290957. And of course it's like, oh, that doesn't exist. And device port, which would interfere with this one. I can also do, okay, so let's see what happens if I run it again. So now it just runs. It really should not be slow though. And it said, it timed out, this is what I was wearing. So I had this primitive on this serial saver thing that says, wait until you see this output. And it says, oh, I timed out, I couldn't see it. But then if I look here, it did find it. So, but also like the regular serial output didn't have anything. So like CircuitPython didn't completely run. But like this is the output of the bsim, so it looks like it's talking to each other. So like I'm getting into this threading mess of like what's running, what has its output correct, and why isn't it being captured? And I'm not sure why. You know what? Maybe I should just let these break us. So it should be that I have separate threads running them all, but they're not, they still like kind of block each other, I think. I think maybe what I need to do is I need to give up on the thread idea. And the thing I was trying to avoid was using select But the nice thing about select is I think it will actually work. Although I don't know if select works with PySerial. So in this case, like we're still waiting for the bsim to exit. We're still not getting output on. We're getting no CircuitPython output, which I don't know why. And read empty for like I'm not confident in my ability to get an agent to generate what I actually want. Otherwise, I'd be trying to use an agent for this. Although, I haven't tried Claude yet. I haven't tried Opus. So maybe, so we are getting read empties for debug and debug. Debug is just, oh, read empty for your 0. So it should be end of file, but it shouldn't be doing end of file. So we have what, 10 minutes? So if folks have questions, let me know. Otherwise, I think what I'm going to do is I'm going to just see if Claude can do it. See if Opus can do it. So let's just checkpoint here, just so that we can get good diffs. I don't care. I'm gonna rebase it once I figure out how to get it done. And let's go to Py. Oh, see, this is the thing that added the read line with timeout. Let's just do new and model. And I was using 5.3 Codex, but let's use Opus 4.6. And let me get this. And it doesn't adjust very well. It's supposed to be good at that. So we're doing Opus 4.6, that's in the bottom right-hand side. Fix the bsim basic test. Something funny happening, capturing all of the different serial streams. Let's just see what it does. Is that failure exit serial printing code not multi-CircuitPython device aware yet? I think it should be. It should be. It was printing for instance 0 and for instance 1, I think. So it's correctly running it, and we'll see what it says. It creates, starts a reader thread. But wait, it's thinking. It's so entertaining. It's having the same thought process. The tail is empty, so it isn't capturing anything, but I also see that it is printing it from where? Must be coming from CircuitPython processes standard error. No. It's printed during the test or fixture teardown. All right, well, it's exploring. And this is like, this goes to the like, it may or may not work. If it does work, it saved me time because I spent a lot of today on this. If it doesn't work, oh well. And I just like did a commit, so. Standard error none means standard error inherits from the parent. Okay, it thinks it's figured it out. But this is interesting. So this blue stuff is like a temporary Python script it's running. So it's got this Python C and it's giving it a shot. Like it's experimenting, which is just like something that I simply like, it would take me so much time to do. It's just wild to watch it. Like it's trying to like try different things and figure it out. Native sim process reads the first line from standard out expecting connecting to sudo tty, but actually gets the bsim connection message. It still hasn't fixed it. So it's still going. Any other questions before we wrap up? I guess we've got a few more minutes. The fixture does include the -v-9. Is C standard IO buffering? The 5 binary writes to a pipe instead of a terminal. Standard out becomes fully buffered. It's avoiding my serial saver thing, which is not really what I want it to do. Phi standard out is C standard out fully buffered because it's writing to a pipe, not a terminal. Data stays in the Phi process's internal buffer until the process exits, so serial saver never sees the cleaning up in time. Finish sim waits for cleaning up before shutting down the service, but the Phi won't produce that output until the sim ends and the process exits. The fix changed finish sim to shut down devices first, and then wait for the Phi process to exit, read its output afterwards instead of using a serial saver. Now let's run the test, and it still failed. Oh, yes. Let's see if Opus can figure it out. What a way to end a Friday, huh? I guess I usually work a little bit more after screen now. I'd love to finish it up. There's at least one other thing I need to do, which maybe I could do right now while this is going, is that it introduces a bunch of diffs that I don't, a bunch of translations that I don't want. This is my one gripe with virtual terminals, is that Sublime Merge doesn't, I can't just open another Sublime Merge, it would take me back to the other one. but then I'm in the YOLO one, so I'll look at the YOLO thing. So here's what I was hoping to make my PR out of. And then you can see here that like CircuitPython.pot has a bunch of changes. It's like super verbose error reporting that I just don't need. So, oh, it thinks it's making progress. Okay, let me exit this. That was git review stuff. Let's add a second one. Let's see if we can drive two at the same time. And we'll switch this one back to 3.6. I'm paying for the Codex. Ooh, should we try Spark? It's supposed to be super quick. Reduce number of new translations. It's added by the Belio implementation. Instead use the raise Zephyr error function. Correct. These are in the same folder. I think it's going to be okay because they're kind of doing two separate things. I have separate work trees for each virtual desktop, but I'm trying to do this. So it's doing what I wanted. It's being quick about it. So it's still crunching away. The 5-part works. Use communicate to properly drain the standard out pipe. Right, so I want Beely audio today with Matter. Sorry, no. These LLMs are supposed to be able to do all this, right? Without my help at all? The serial stream is capturing in the test infrastructure. We'll see. We'll see what it comes up with. I'm pretty tired. It's a red herring. I do have more test refactoring too. I want to refactor the way that the Zephyr samples are added into it. Because I have these two bsim cases. It's a CircuitPython, and a CircuitPython and a Zephyr example, or a Zephyr sample. Okay. It says it fixed it. Phi standard out was fully standard out buffered. The old codes tried to wait for cleaning thread, but it's always timing out. Finish sim was wrong. I tried to wait for the Phi to finish before shutting down devices, but CP devices enter the REPL after code.py and keep the simulation running until sim length, which could be slower than real time. The Phi wouldn't exit in time. Reader loop crashed on disconnect. Remove serial saver reach for Phi standard out because full buffering makes streaming unreliable. How do we disable streaming? Change appliance not to communicate. Finish sim now shuts down devices first, and then uses communicate to wait for the phi. Sleep and pull instead of trying to do stream read. Calls before finish, produce output before. Added wait for bsim ready calls. It's really interesting how AI coding agents are changing what it means to be a software engineer. I'm 61, but have always made a point to stay on top of technology. I learned object-oriented, so this is just another way to do my job better. Yeah, I agree. It's just another tool. Oh, it's putting it back. Standard buff. We can prefix the phi command with standard buff OL to force line buffered standard out. What? Huh. I never knew about that. This is where they excel as well. So like let's just standard. What the heck? I'm confusing it. What is going on? I tried and you're like capturing my output. Or run command with modified buffering operations for its standard streams. Adjust input buffering, output buffering, and error buffering. It will be line buffered. If it's 0, the corresponding stream will be unbuffered. If it's unbuffered, does it drop it or does it? Okay. This removes those 2 translation string error additions. What folder am I in? Can I do that? No. No. Quit. So one thing that's cool, Pi has the ability to resume. Although all right, I gotta wrap up. Test timing. How are you finding Pi versus Claude code? I'm also curious if you could pass the transcript of your refactor request with the 2 test cases and fire off a GitHub issue copilot session where I'll ping you for review. If your offline sim tests were a strong enough case, it could get there in theory. So Pi, I've been trying, so Pi is like the agent harness. So it's the thing that's like setting a system prompt and providing the tools that the LLM will call. I like the stdbuf OL trick. Like it would, I don't know if I would ever have found that. Like, that's what it's good for. Okay, I'm gonna keep working on this, but I am trying to do hour-long deep dives in that too. So let's do this. Pi was better than Codex for things because it's not sandboxing, which is a little crazy, and it's not even asking you about anything. Like whether it can do anything, so it's like pretty YOLO-y, but they wanted to make Pi so that it wouldn't change out from menu. So trying the different harnesses like Claude Code and Codex are still worthwhile, just like trying different models as well. It's interesting to see the models from the different harnesses too. Anyway, thanks again, everybody. This has been another deep dive with Scott. I think I'm around next week. It is a long weekend in the US here, so Mondays, if you come to the CircuitPython meetings on Monday, it will be Tuesday next week. If you want to support me, you can go to adafruit.com and purchase hardware from them. They pay me to do this, which is great. If you have any questions or you want to join the Discord, the URL is adafru.it/discord. And that's about it. I'm going to wrap up here. I have a Valentine's Day party at daycare to go to and not too long, so I only have a little bit of time. So anyway, thanks to DCD preemptively for timecodes, and have a great weekend, everybody. I'll talk to you next week. It's a rainy day here, so I'll show you. It's been so nice. You can see the drops a little bit. It's cloudy and rainy. Cloudy and rainy here in Seattle.